welcome to another tutorial by Recurrent Reflections. Today we'll be focusing on hyperbolic function. On this hyperbolic function, we are focusing on the type of hyperbolic function where there is a shift horizontally. So that hyperbolic function has a general formula, which is y is equal to a divided by x plus q, where a and q are constants. So we have few guidelines that we have to follow, or that you always have to remember when you deal with hyperbolic functions. On the previous tutorial we discussed what happens if a is greater than 0, if a is less than 0. This one we are going to discuss what's happened if a is between 0 and 1. So in that case we say that as a tends to as a tends to 0, y, which is this y, moves closer to the axis than it moves closer to the axis than y is equal to 1 divided by x. So the other one that we are going to focus on will be what happens if a is greater than 1. Then we say that y will be further away from both axes. Then y is equal to 1 over x. So obviously we have to get to what happens if a is less than minus 1. In this case, y will be further away from both axes also, than y is equal to minus 1 over x. After that, then we focus on what happens if a is between minus 1 and 0. Then we see that as a tends to 0, y moves closer to the axis. Then y is equal to minus 1 over x. So right now we are going to come to the value of p. What happens if q is greater than 0? Our function of y will be shifted. So y shift vertically by q units. Same applies if q is less than 0. Y will also shift by will shift downward on the negative side. So this one, when it's positive or when it's greater than 0, it shifts upwards. So right now we are going to get to a part where we sketch the function, or we're going to give you an example and show you how we sketch it and how it's going to look like. Also note that the vertical asymptote remain to be x is equal to 0, but the horizontal asymptote becomes y is equal to q. So q is also is equal to the value of the horizontal asymptote. So now let's get to sketching our function. Let's find an open space. Now the question says that sketch the function of f of x is equal to minus 4 divided by x minus 2. So the first thing that we are going to do, we are going to draw down our table, then we write the points. We are going to name our axis first, which is going to be minus 4 minus 2 minus 1. This will be our 0, then 1, 2, then 4. Then from there you substitute the value of x here on x, then you find the value of y. So when you put in minus 4, you're going to get minus 1. When you put in minus 2, you're going to get 0, then 2, then undefined, then you're going to get minus 6, you're going to get minus 4, you're going to get minus 3. Then from this point we are going to draw down our Cartesian plane so that we'll be able to start sketching our graph right away. Now let's start drawing our axis, our y-axis, our x-axis, then our y-axis. It will be the Cartesian plane that we are going to use. So right now we're going to label all of them, then you're going to label the points. Now that we have our Cartesian plane drawn accordingly, we are going to start plotting our points, which is we're going to start with minus 4 and 1. So it will be our minus 4 and minus 1, so it's going to be somewhere here. Just going to do a dot. Let's use a different color to symbolize the dots. We're going to use a red. So minus 4 and 1, minus 1, minus 2 and 0. It's going to be here. And minus 1 and 2. Minus 1 and 2 is going to be here. And let's try to make it look, yeah. Then our graph is never going to touch our y-axis this side, since it's undefined on 0. So then after that we're going to go to 1. So 1 is going to be minus 6. So 1 and minus 6 is going to be here. And then we are going to have 2 and minus 4. 2 and minus 4 is going to be here. And we are going to have 4 and minus 3, which is going to be here. And quickly you'll be able to notice that we have from the function here, you'll be able to notice that our horizontal asymptote is minus 2. So we are going to use a different color. In this case we are going to choose yellow to symbolize our horizontal asymptote. We're just going to draw a straight line in yellow here to symbolize that this is where on our y-axis the graph is not supposed to touch this yellow line. And this horizontal asymptote is the equation of the horizontal asymptote is y is equal to minus 2. The vertical one is here, so it's going to be x is equal to 0. So without wasting any time, let's go ahead and start sketching our graph. The graph is supposed to touch all these points here. So it's going to, let's start it somewhere here, then take it off to here. So it's supposed to touch this point. And also this point. So this is how our graph is going to curve on the other side. So on this other side it's going to curve like let's make it okay, sorry about that. Touching all the points. So this is going to be our function of f of x. This is what is going to be our function of f of x. Then we just add arrows here to show that the function is continuing on either directions. So this is the function of f of x. Thanks for watching, and don't forget to like, share our videos, and click here to subscribe, and also click here to watch more educational videos from Recurring Reflections. And don't forget to get in touch with us on our social medias account.